For this first lesson, we're going to look at solving a system of equations graphically. So using our graphing calculators to find the points where they intersect, which should be solutions for the system. A system of equations consists of two or more equations that are considered together, which means that the x values are the same between them, the y values are the same between them. So it can only be true if they have matching x and matching y values. The solution or solutions to the system is always going to be represented in an ordered pair, x, y, where the graphs intersect and must satisfy all of the equations in the system. In other words, the solutions are the common points that exist on the graph. If I have a linear quadratic system, then that means that I have one equation that's going to be quadratic, and the other equation is going to be a straight line. Now, it is possible for me to have two solutions where the line intersects the quadratic twice. It's possible for there to be no solutions where the line never actually intersects. And there's a couple of ways we can have one solution. We could have one solution where the line touches it right along the curve once, but never touches it again, and there would be my one solution. Or I can have a solution where it's either in the form of x equals, where if I had a perfectly vertical line, it would cross once and never touch it again. Or if I have y equals, where it's a perfectly horizontal line, and y equals the q value or the y value at the vertex, and it's going to touch once on that point and never touch again. We're talking about a tangent to the curve. A tangent line is a line that touches the curve at a point. So in this case, we can see that with the one solution there. The point of tangency is the exact coordinates of where this takes place. We can have a quadratic-quadratic system where we have two quadratic equations, and the principle behind it is pretty much the same. I'm going to have one quadratic equation and then I'm going to have a second quadratic equation. There's a couple of ways where we can see where it has one solution. It could be facing the other direction, but connect at one point like this. Or the more common method is that it shares a vertex but has a different a value. Whether it's positive or negative, the value of a is not the same. And if it's not the same, they're going to touch once at the vertex and never touch each other again. We could have two solutions, something like this, where they connect at 2 points. We could have no solutions, where I could have it open up inside, or I could have it open down and away from the other one. And if I have infinite solutions, that would be if I had like a general form equation and a vertex form equation, and they were actually equivalent equations, or they were collinear. So, the steps for solving linear quadratic or quadratic systems graphically is always the same. First, we got to isolate y, because we put the y equals into our calculator. After we enter it into our calculator, we're going to adjust the window settings so that we can actually see the points that they intersect. If I don't see it on the calculator, then my calculator won't solve it. Then I'm going to find the solution. If you have a TI-83 or 84, it's going to be second trace 5, and then hit enter 3 times to select your equations that you're using and then select the point. If you have a Casio, then it's going to be shift F5 and then F5 again to find those points where they cross. The solutions are always going to be in the ordered pair of x, y, where I could have obviously one solution, two solutions, no solutions, or infinite solutions. And then I need to verify the solutions by subbing the points for x and y into both equations, which means that if I have two equations and I have two solutions, I have to do 4 verifications to prove that it works for both possible solutions in both possible equations. So let's try this out. For the first one, we have x minus y plus 1 is equal to 0, or x squared minus 6x plus y is equal to 3. Well, I'm going to call this one y1. I'm going to get y by itself, so I'm going to say that negative y is equal to negative x minus 1, or y is equal to x plus 1. And that's what I'm graphing in here. Y is equal to x plus 1. In the second case, I have y is equal to, and this is going to be my y2, negative x squared plus 6x minus 3. For this one, I'm going to use the window settings of negative 10, positive 10, and 1, negative 10, positive 10, and 1. And I'm going to do a sketch. Doesn't have to be perfect, but a pretty good sketch of what this is going to look like. So I'm going to have my linear function is going to come up like this. I'm going to have my quadratic function is going to come up like this. And then I can see that I have 2 points where they intersect, one here and one here. And when I solve those points of intersection, I get the point of the one on the left is 1 and 2, and the one on the right is 4 and 5. It's not bad to write those right into your graph as well. So now I just need to prove that these actually work. So I'm going to split this into 4 sections because I have 2 solutions and I have 2 equations. And then I'm going to sub my first solution, 1 and 2, into my first equation, x minus y plus 1 is equal to 0. So I'm going to state that for the first one, 1 minus 2 plus 1 is equal to 0. Always making sure that when we're subbing in for a variable, we replace it with brackets. In this case, when I combine them, 0 is equal to 0, left side is equal to right side, and this one works. Sub my first solution to the second equation. Negative, 1 squared minus 6 times 1 plus 2 plus 3 is equal to 0. This is going to give me 1 minus 6, 2 and 3 are going to make plus 5 equals 0, and 0 is still going to equal 0. Left side is equal to the right side. Sub my second solution into the first equation. 4 minus 5 plus 1 is equal to 0, and this one balances out as well. And I do the same thing with my second equation. 4 squared minus 6 times 4 plus 5 plus 3 is equal to 0. 16 minus 24, 5 and 3 is going to be 8, is equal to 0, and these ones balance out as well. So both solutions work in both equations. This is my correct set of solutions. In the second set, I have a quadratic-quadratic system. I'm still going to follow the same process. So I'm going to say this is going to be y1, and I'm going to start by isolating that. So I'm going to move everything to the other side, and I'm going to say that y is equal to negative 2x squared minus 16x minus 26. And that's what I'm going to be graphing in. For my second equation, I'm going to get negative y is equal to negative x squared minus 8x minus 19, or y is going to equal positive x squared plus 8x plus 19. I'm going to graph these into my calculator. For this one, I put in the window settings of -10, +2 and 1, and -5, +10 and 1. And I'm going to graph out what I see. And I see something like this. And I have 2 points where they intersect. In this case, I saw it at -5 and 4 and -3 and 4. So I need to verify with all of these cases. I'm going to start with my first solution in my first equation, and I'm going to say that if I have 2 times -5 squared plus 16 times -5 plus 4, it should give me -26. Well, this is going to be 2 times 25 minus 80 plus 4 is equal to -26. 50 minus 76 is equal to -26, or -26 is equal to -26. And the left side is equal to the right side, and this works. My first solution in the second equation is going to be -5 squared plus 8 times -5 minus 4 is equal to -19. 25 minus 40 minus 4 is equal to -19, and when I combine them all together, -19 is equal to -19, and the left side is equal to the right side. So my first solution works. My second solution in the first equation, I'm going to get 2 times -3 squared plus 16 times -3 plus 4 is equal to -26. This is going to give me 2 times 9 minus 48 plus 4 is equal to -26. 18 minus 44 is equal to -26, and -26 is equal to -26, so my left side is equal to the right side. So far, so good. My second solution into my second equation is going to give me -3 squared plus 8 times -3 plus, sorry, not plus, minus 4 is equal to -19. This is going to give me 9 minus 24 minus 4 is equal to -19, and when I combine them all together, -19 equals -19, and my left side equals my right side. And once again, both of these solutions work.